Okay guys, here again, Dr. Diaz. Let's go fast here. Remember, tomorrow we have class at 1. It's more like a review if you have questions. Okay, anyway, I'm going to solve some of the problems here from the review. Some of you may be asking. Look at this one. So let's go fast here. Okay, this one, it says the circuit show, blah, blah, blah. And they're asking you what's the current in the resistor of 1 ohms, which is this one, and the 3 ohms, which is this one, and the 4 ohm, which is this one. Now, look at this one. This circuit here is the same as this circuit. Ta-da! Like this one. You see? I changed it a little bit because I like to read it this way. Anyway, here it is. We have the 2 ohm resistor, 2 ohm resistor, the 1 ohm resistor, 1 ohm resistor, and here the 5, 4, 3, because this 3, 4, and 5 resistors, they are in parallel. You see, that's what it means here. It's one junction. The current has 2, actually 3 possible paths. It means these 3 are in parallel. And then these 3 parallel are in series with these 2. So let's solve these 3 that are in parallel, and let's turn these into one single resistor equivalent. So because these 3 are in parallel, the resistor equivalent of these 3 will be 1 over 1 over 5 plus 1 over 4 plus 1 over 3. And the answer is 1.3 ohm is their resistance equivalent. So that means that this circuit is equivalent to this one, to this circuit. Now that we have 3 resistors in series, 1 ohm, 2 ohms, and 1.3, the total resistance is going to be what? Right here, total resistance is going to be 2 ohms plus 1.3 ohms plus 1 ohms. Here we have the total resistance 4.3 ohms. Now the problem is asking how much is the current for the resistor of 1 ohms, the resistor of 3 ohms, and the resistor of 4 ohms. So the first thing we have to calculate is the total current. Total current is going to be equal to total voltage divided by total resistance, which is going to be 12 volts divided by 4.3 ohms, and the answer is, so the answer is 2.8 amperes. So the total current is 2.8 ampere. So that means when it leaves here the battery, 2.8 goes through this resistor, 2.8 go to this one, and this one, remember, represents these 3 here, and 2.8 goes to this one. So now right away you know that the answer for the first one is just 2.8 amperes. Haha, good. And that is because this one is in series with all these 3, and the current that goes in resistor in series is always the same. What about this one, 3 and 4? Oh, now you have to find, since you have a resistor, you need to find out the voltage. How we do that? Well, first look at this one. Look at this circuit here. We know that the total is 12 because these 3 are in series. It means that out of this 12, something goes here, something goes here, and something goes here, but the sum of the 3 voltages that go through these 3 resistors is going to be equal to 12. So what we have to do is find how much it went here, how much it went here, and what is left. Well, 12 minus whatever drop here is going to be for the last one. So here we go. How much went to this resistor? We know that the total current here, because it's in series, 2.8. So we can call that the voltage for the 2 ohm resistor is going to be the current that it goes to the 2 ohm resistor times the resistor times the resistance. But we know that I2 ohm is the same as the total, the same as I1. We can put it equal to I2 ohms, which is 2.8 times 2, and we got 5.6 volt. The same thing if we do with this one here, because it's very easy, it will be what? Voltage in the first resistor, or a resistor of 1 ohm, is going to be its current times the resistor of that 1 ohm, which is just what? 1 ohm times 2.8 is 2.8, right? So if we add these two, we get 8.4 voltage. So there is 8.4 voltage among these two. Whatever is left is for this one. So what is left, let's say the voltage for that 1.3 ohm is going to be 12 minus 8.4, and that's 3.6. Why is that important? Because if the voltage for this one is 3.6, it means it is 3.6 for this one, 3.6 for this one, 3.6 for this one, because these all 3 are in parallel. They have the same voltage. So how much is going to be the current for this one? Is going to be, well, that voltage we found here that is parallel is the same for them, 3.6 volts divided by the resistor, which is 3 ohms. And how much is going to be for the 4 ohms? It's going to be the same, 3.6. Well, not the same numerical, but it's 3.6 volts divided by 4 ohms. And if you do this, you will get that the current here, 3.6 divided by 3 is 1.2 amperes, and 3.6 divided by 4 is 0.9 ampere. And if you add these two, you will get a 2.8, right? Because remember, what it happens here is the current that goes through this one is the total, 2.8. And the one that went through this one is the total, 2.8. But when the current reaches this junction, part goes here and part keep going. And when it reaches this junction, part goes here, part keep going. Oh, actually, it's not. If you add these two, it's not going to give you a 2.8, but it's going to give you this plus whatever went here is going to be equal to 2.8. Because now I notice this is going to be 2.1. So that means that even though it's not asking, but you can calculate it, for the resistor of 5 ohms, it's going to be what? The current for the 5 ohms, and they're not asking, but you can do it. It's going to be 5, it's not 5 volts, it's 3.6 divided by 5 ohms. There you have it. 3.6 divided by 5 ohms is 0.7 amperes. Oops, I forgot units. And now, if you add 0.7 plus 1.2 plus 0.9, that will give you the total, which is 2.8. Okay, I hope this helped a little bit. I'm going to do another one in a second. Guys. Now for this one. I think what they're asking, well, actually, I've read it now. What they're asking is how much is the current that is going through this resistor of 100 ampere. So, there's other two devices here, but these two, if you use the rule of loops, the only one that it matters is this one. So it's only these. So this one is like they are not there when you're doing the loop rule, right? And the loop rule basically says that the sum of the potential in a loop is going to be equal to 0, and the loop we're going to use this one, we're going to call it loop 1. Now, because this is the biggest battery, and we know it's polarized plus minus, this one is plus minus here. When the current goes through this one here, we polarize this one plus, and this one minus. So here we use the loop, and we look at the direction of the arrow here. When it goes through this, and the only 3 devices we need to take in consideration is going to be this one, and this one. Forget about these 2. Blast. So here, let me do this again in a second. Okay, we have a new circuit here because now you can see clear here because I put a bunch of marks there. Okay, we already polarized this one plus minus, this one plus minus, this one is plus minus because this is a battery. We use the loop here. When the arrow goes here, look at the positive side of the battery. We do 7 volts positive. When it goes here, it looks at the negative side, so it's going to be minus I times 100 ohms. And then when we go here, it would end up looking at the negative side, so it's going to be minus 3 volts, and this is equal to 0. So you see 7 minus 3 is going to be 4 volts minus I 100 ohms is equal to 0. We send the I 100 to the side. We have 4 volts is equal to I times 100 ohms. We divide both sides by 100. Let me put it. It looks like it's 100 ohms. Divide by 100 ohms, and you have that I is equal to 0.04 ampere. Yay! Okay, there it is. It's 0.04 amperes. Finally. Hey guys, skip problem 9 and 10. Those are not going to be on the test. They're too difficult for you guys, and in class will be good, but not here. We're not in class. Okay, so skip those 2, 9 and 10. Let's go to this one, 11. You see, you all got confused. What the heck they're asking? That is called the Lorentz force. Read the book. Oh, now you don't have the book. Now you're in trouble. Well, okay. The Lorentz force basically says that the net force is what? The sum of the electric force plus magnetic force. And the electric force, if you remember, is going to be Q times E, right? And the magnetic force, if you remember, is QV times B. And this is the magnitude of forces. Okay, so in this case, the only thing you have to do is, well, you can put QE plus QVB. You can take Q as a common factor. The problem says it is an electron. You just do substitute the numbers there. That's it, guys. Bye bye. And direction will be according to the right hand rule. Bye.